Okie doke, welcome to the first video on the macroeconomics of sustainability. And it's the introduction to my part of the course. Let's see if I can get these. So, macroeconomics of sustainability. So what's macroeconomics? In macroeconomics, we study the behavior and performance of economies as a whole, rather than focusing on subsets of households or firms. We're often interested in the long run. How do we regulate the economy to achieve the long run outcomes we're after? And of course, the link to sustainability should be obvious. So what about sustainability? Well, as you know, sustainability includes a lot of different things, but we're going to focus entirely on problems related to the environment and natural resources. So we're not talking about social sustainability, things like inequality, which could also certainly fit under the macroeconomics of sustainability. And we're not leaving those things out because they're not important. We've just decided to focus on what we're good at, which is also, of course, our special area within SOU, within the department. And also, it's my main area of expertise. And Chandra's, I guess. And note that Chandra and I have been planning the course together from the beginning, which is quite a long time ago actually. It's taken a long time to come to fruition. So I'm super glad we're finally getting started. Okay, so what are the four biggest sustainability concerns related, as I said, to environment and natural resources? Well, that is of course debatable, but I've made this list. The exhaustion of non-renewable resources, local pollution, global pollution, and biodiversity loss. So, exhaustion of non-renewable resources, it's pretty clear what that's all about. It's actually, as we'll see, was a huge concern in the 70s. It's very much fallen off the agenda since then. Local pollution, a massive concern. As we'll see, and as most of you will know, things have got an awful lot better in rich countries, but they're still absolutely dire in many countries of the world. Global pollution, on the other hand, also a massive problem, and that is clearly a growing problem. Admittedly, we've got CFCs, what the Swedes call freoner, under control, but for instance, carbon dioxide emissions are very much not under control. And finally, the sort of coming concern, which has shot up the agenda in the last 10 years or so, rapidly sort of catching up with climate change, is biodiversity loss. So those are the four, that's my list of the four biggest concerns, and not surprisingly, we're going to talk about them in the course. My focus in my part of the course, so I have roughly the first half of the course, a bit more than half, or the material, is first to build a workhorse model of natural resource use and polluting emissions. And of course, the two go together in the same model because most polluting emissions are a direct result of natural resource use. This model is useful for understanding all four of our main problems. Having built the model, I apply and adapt it to understand the first two problems, that is, exhaustion of non-renewables and local pollution. Then Chandra takes over. I won't say a lot about global pollution or biodiversity loss in the videos, but in class we might end up talking about them. That's kind of up to you guys. Okey-doke. Methodology. As befits a PhD course in economics, we're going to think and talk a lot about methodology. We're going to trace the development from the 70s through to today. So back in the 70s, models tended to be very abstract, or even through, until pretty recently, most of the models were very abstract. We sort of talked about things like abatement costs, extraction costs and stuff. We didn't build models with clear physical interpretations. But thankfully, the latter kind of models are taking over. We'll also see that there's been a gradual shift from a kind of anything goes approach in theoretical work, to an approach in which theoretical models have to be sort of anchored in what we actually know about how economies work, what the empirical regularities are, or the stylized facts. But there's still far too many anything goes models, actually, as we'll see. We'll also talk a bit and think a bit about welfare economics. That should be always good practice, or crucial to put welfare economics at the center of things. What are the externalities? What would the first best look like? How can we get towards the first best with the help of policy instruments? Okey-doke. What are we gonna find? A very quick preview of some of the things. So we're going to build a workhorse model that looks a bit like this. Okay, with households and firms and the sort of energy and resource sector here with primary inputs then getting processed and fed in. So here we can think of this as an energy sector, right? But we can also adapt this to think of natural resources more generally. Here we've got labor supplied by households. It can go into any of these sectors. No capital here. This is a very stripped down workhorse. We can add capital here, of course. And of course we have emissions, which are typically closely associated with these resource sectors. In this case, these emissions are creating a stock in the atmosphere, which then come back and affect production. They could also, that arrow could go the other way, they might affect utility. It doesn't have to be via the atmosphere, etc. But this is a very useful general picture of how we can model resource use and pollution. And I haven't included biodiversity here. If we wanted to include biodiversity, we should add a third sector here. We've got two sectors here. You could think of it as a service sector and a manufacturing sector. And of course, the demand for energy and materials is going to differ between these. If we wanted to extend this workhorse to think about biodiversity, we should add an agricultural sector, right? Okay, so that's our workhorse model, which we're going to get to after a lot of going through other kinds of models. Exhaustion and non-renewables, it's fallen off the agenda big time. But we're going to spend quite a lot of time talking about it because it was a big focus back in the 70s, which is where we start looking at the literature. Makes a big difference whether we're looking at energy, materials, or land. In each case, we have limited supplies, and there's a range of adaptations available, mechanisms available in the economy. One of the reasons it's not obviously a huge problem is that there aren't obvious market failures, at least in well-run economies. We have well-defined property rights. For many resources, market power is relatively limited, and so on. But these are the areas, property rights, market power, and discounting, where there are potential market failures, which we won't actually talk about a lot in the course, or in my part anyway. I think Chandra might well talk about discounting, but you could potentially look at these areas for your essay. Local pollution, a massive welfare problem, but signs for the future are good. Right? In the richer countries, local pollution has fallen drastically and continues to fall, and we have every reason to expect to see the same thing in low-income countries as they start to get richer. A bunch of explanations for those observations have been offered, and they're only recently grounded in models with physical interpretations. But basically, one of the very first explanations that was suggested is the correct one, or the dominant one. That increasing willingness to pay for a clean environment drives policy, which pushes up the cost of polluting and makes firms switch from cheap and dirty technology to clean and expensive. So we'll be seeing that in a lot more detail later on. Global pollution, not my focus, more Chandra's job. There's actually a lot of similarities to the local pollution problems and the policy prescriptions, but it's a lot more complicated. Global pollutions tend to be long-lived, and some of the pollutants like carbon dioxide, they're like everywhere in the economy. It's much harder to stop. We need international cooperation, and we often struggle with uncertainty and disagreement about damages, and that is all much harder to deal with in international context. Biodiversity loss, also not covered in my part of the course. I might just mention the Dasgupta report, the modeling in which shows that we've got a long way to go in understanding economics of biodiversity loss. But a key feature for biodiversity is land. Like, what do we choose to use the surface area of the earth for? Okay, I think we're near the end. Yeah, we are. Last couple of slides. The pedagogical approach. So I'm going to be recording videos for you to study in advance, and then the focus in class is on discussions. I'll raise lots of things for you to think about during the videos, and my plan is also to provide a list of questions for you to think about before each time we meet in class. I'll try to keep the videos around about 15 minutes each, so that it's easy to navigate through the videos and between videos to keep track of what I'm talking about in each video. Overall, so I'm not going to tell you about Chandra's pedagogical approach. That's up to him to tell you about. But overall, as you know, we've got a combination of an essay plus seminar and an exam. For the essay, the idea is you pick your own topic to study more deeply. We'll tell you more about that, of course. And more details about the exam will come very soon. Okay, we will make sure that you know roughly what to expect well in advance, so you can prepare properly. Okay, that's the end of this video.